Standard quantum field theory represents the vacuum as an abstract stage populated by a chaotic boil of virtual particles. But if we abandon that abstraction, the vacuum mathematically resolves into a dynamic, continuous elastic fluid, the tau metric. Instead of treating space as a void where independent fields happen to interact, the tau metric framework models the fabric of space itself as a physically compressible medium. This table outlines the kinematic nomenclature governing both the expanding macrocosm and localized topological boundaries. The variable tau defines the global time of this continuous fluid metric, while v0 tracks the macroscopic advection velocity of the expanding continuum. By applying the strict rules of classical fluid dynamics to this metric, we bypass abstract quantum interpretations. Localized phenomena evaluate strictly as the deterministic result of fluid advection and geometric strain. To test this, we will apply this continuum framework directly to three standing challenges in modern physics: fundamental vacuum energy, the mechanical origin of Casimir force, and the century-old Poincare mass anomaly. Formulating physical law requires anchoring all interactions in the Eulerian material derivatives of a physical continuum, stripping away the mathematical crutches of point-particle mechanics. We begin by replacing Maxwell's abstract electromagnetic constants with the Newton-Laplace limits for classical acoustics. This visualization shows the explicit mathematical mapping between classical electrical circuits and continuous fluid mechanics. The resistance, inductance, and capacitance of empty space map perfectly to acoustic fluid limits. Vacuum permittivity, denoted as epsilon naught, evaluates geometrically as the exact inertial mass density of the quiescent tau fluid. Vacuum permeability, mu naught, equates to the inverse macroscopic shear modulus. It dictates the structural mechanical compliance of the fluid under isotropic tension. The physical consequence of this isomorphism is strict. The underlying background vacuum operates as a mechanically compressible fluid. This equation demonstrates the classical electrical energy storage for an inductor, 1/2 L times I squared. Substituting the electromagnetic variables with our derived fluid mechanical operators replaces inductance with mechanical compliance, and electrical current with macroscopic mechanical force. What legacy physics categorizes as stored electromagnetic energy calculates identically as the static elastic potential energy of a longitudinally strained tau metric. We can scale this fluid evaluation outward to the absolute macroscopic boundary conditions of the universe. This diagram illustrates a continuous acoustic standing wave, bounded physically by the macroscopic scale radius of the expanding causal horizon, RH. The fundamental geometric wave vector is mathematically locked to the inverse of this spatial boundary. This inverse relationship isolates the absolute minimal continuous momentum sustained by the continuum, deriving the baseline for vacuum energy. To evaluate the internal mechanical strain of this expanding boundary, we utilize the continuous fluid Lagrangian. Applying the Legendre transform transitions the geometric evaluation from momentum phase space, P, directly into velocity phase space, V. We then substitute the velocity boundary condition, setting the macroscopic fluid advection equal to the speed of light, c. The variables cancel entirely. The continuous geometric action mathematically evaluates to exactly 0. Because the action is 0, the macroscopic vacuum boundary uncurls as an absolute kinematic null manifold. It expands naturally without accumulating internal structural strain or mechanical friction. Dark energy and vacuum expansion do not require the introduction of theoretical anomalous repulsive forces. They represent the native, friction-free hydrostatic state of a bounded elastic continuum. That null action defines the macrocosmos, but the precise mechanics of the tau fluid scale uniformly down to submicron physical boundaries. Place microscopic parallel plates into a fluctuating liquid matrix. The space between the plates calms, while the external waves continue to agitate the outer surfaces. This imposes a rigid geometric requirement. Any acoustic vacuum mode possessing a half wavelength greater than the physical distance between the plates is forbidden from existing in that gap. This chart shows the formation of a macroscopic acoustic stopband. The parallel boundary aggressively filters and excludes low-frequency fluid fluctuations from the internal volume. The inward pressure on the plates does not require the continuous creation and destruction of virtual quantum particles. The excluded internal wave modes force a localized fluid dynamic suction, creating a pressure differential that perfectly derives the exact baseline pressure of the Casimir force. The Casimir effect resolves as classical hydrostatics. It is the mechanical crush of the external continuous tau fluid driving inward against a geometrically depleted internal zone. We can apply these exact thermodynamic principles to localized topological defects, specifically the fluid boundaries that constitute fundamental particles. This visualization applies the Euler thermodynamic relation to a closed defect. We evaluate the total enthalpy, the complete energy required to create the internal geometric strain of the particle. For a radiation-dominated acoustic standing wave, the internal kinetic energy equates strictly to 3 times the pressure-volume product. We substitute 3 PV for U. We apply the Legendre transformation with respect to the localized internal pressure and the specifically displaced volume of the fluid boundary. The state function fully resolves, proving the total absolute thermodynamic boundary energy equals exactly 4/3 of the internal energy. This mechanical resolution identifies the exact mathematical origin of the Abraham-Lorentz-Poincare mass paradox. The excess 1/3 geometric fraction is not an anomaly. It quantifies the continuous mechanical work, PV, required for the particle to displace the background elastic vacuum. The particle boundary maintains equilibrium, resisting explosive internal expansion, because its outward work is perfectly neutralized by the inward macroscopic isotropic tension of the tau matrix itself. Rest mass cannot evaluate as an isolated, independent property. It exists as the permanent thermodynamic interaction of a topological boundary fighting against the baseline hydrostatic pressure of the continuum. The tau metric demands mathematical symmetry. The expanding causal horizon, the rigid Casimir gap, and the internal strain of a localized particle all obey identical mechanical limits. The macroscopic structure of the entire expanding cosmos physically dictates the internal resonance of one single microscopic node. Treating mass and energy as transmutable, abstract substances detached from geometric space breaks the logical chain of physical law. Thermodynamic energy evaluates natively as the absolute physical volume of fluid displaced by a localized boundary. By substituting electrical permittivity and magnetic permeability with continuous mass density and shear modulus, ultraviolet divergences and arbitrary mathematical cutoff limits become physically obsolete. The fluid simply cavitates at its structural yield strength. From the cosmic horizon to localized subatomic particles, physical law evaluates strictly as the deterministic consequence of continuum mechanics operating within a dynamic elastic vacuum.